Cool.
Right.
Yeah, it's a good thing they have this as an alternative. So sure, I'm not sure what the max island problem is, but I want to say I probably haven't done it because there's only one island question I've done, and that's the one where you count, right, the number of islands.
Yeah, so this is a slight variant of that problem. So you're given a two-dimensional array of zeros and ones, where 0 represents water and 1 represents land.
Okay.
Now you have to find the maximum sized island within that, with the condition of identifying the island as it has to be contiguous in in any of the 4 directions. So if there is another land that is diagonally across, then it doesn't count. But if it is directly above, below, left, or right, then you count that as an island. Let me just paste the problem for you.
Okay, got it. I guess just repeating back from how I understood it through your description, I'm given a matrix filled with zeros and ones. 1 indicates land, 0 indicates no land. And basically what I want to do is try to, sorry, I didn't get what the modification part was. The 4 corners thing?
Problem where you count the number of islands, whereas the variation of this is that you want to find the maximum size island.
I see. Okay. So in that case, if I just need to find the maximum size of the island, then instead of doing a count at each step, the thing that I would just have to do is, so the normal count process is I would go through all of the indices in the matrix, and then every single time I find a 1 that I haven't visited before, I would run DFS, right? For the max island problem in that case, all I would have to do is count how many 1s I see in a specific instance of DFS and return the maximum that I find, right?
Yes, that's correct.
Okay.
Maybe you have looked at this problem before, but do you want to, it'd be good if you could discuss a little bit about what the complexity is of the approach and whether there are any alternatives.
Right, so the complexity of running DFS itself ends up being big O of V times E, right? And what we're going to basically end up doing is, because we have the guarantee that, you know, the DFS is only going to cover the entire matrix once, it ends up being just that, right? So really it's big O of n times m, where n and m are the length of row and col in the given matrix. And for the space complexity, because we're doing it, if we choose to do it recursively, because of DFS, we'd end up having, you know, whatever the maximum depth in that is going to be, right? Which I guess potentially you would end up with the exact same thing, in that when you're running DFS, you try to visit every other node, right?
Yeah, that's right.
Cool. So given that, is it okay if I code it out?
Yes.
Sure. So this max island on islands. So first we're just going to set the maximum size to 0, and we want to return that in the end. And what we said we'd do is, for each cell, we're going to try and run DFS on it, right? So we'll have a visited set that we initialize as an empty set, and we'll have our function DFS that starts from some x, y. And then what we want to do is, for y in range, let's call these n and m. So n is going to equal len of islands, and n is going to equal len of islands of 0. So the number of rows and columns for y in range n. For x in range m, what we want to do is run DFS from this x and y. And our DFS is going to have the main logic that we care about. So all DFS is going to say is, from this position, if it's already visited, then we just return. So if x comma y in visited, then we return. Otherwise, we say for option in options, which these are just going to be, or I should name this, for delta x, delta y in options, which I'll fill in. Options is what we want to say is that our mu x, mu y is going to end up equaling x plus delta x, y plus delta y, and we are going to also run DFS from those places. Right, so this is just like the rough overview of what we should have to do, but it's missing the connecting bits, right? So,
yeah. So one quick question: if you have this if xy in visited, how much time do you think that's going to take?
yeah, that's going to be constant, right? Because we're operating on a set. So what we're going to end up doing is, yeah, is a constant time operation, right?
Okay. Any member of a set can be found in constant time. How would you design that?
I'm sorry?
How would you design a constant time set membership operation?
And is that not the guarantee that you end up having? I know in reality it's supposed to be that not membership you're supposed to be able to get in constant time, right? When it comes to, say, something like a Bloom filter. And then I think membership has a probabilistic return on whether it's a member. But I assume that for the implementation of Python sets, when you say that when you say that some item is in a set, you're supposed to get the guarantee, right? That would be constant time. Similar to doing, let's say, I guess, what is it? It's the same as when we use a hash map and we decide to do a key lookup. It would take the hash of the type and see if that exists.
I see. Okay.
Right.
Okay.
So,
okay.
Yeah, this is meant to be similar. So,
but that
right.
will add some space complexity too, right?
Yeah, definitely. Because at worst case, the visited is going to end up being, n times m, right? If they're all ones. Yeah. But that still doesn't change the complexity. I think before we said it would be n times m because of the DFS. So it's still the same complexity. Though I think the DFS isn't necessarily n times m because you'll go back a bit on the call stack, right? Right. So that was one of the things we wanted to say is, if it's x, y is visited, then we return. Alternatively, if, islands of y of x is equal to 0, then we also return because this isn't a 1, so there's no reason to process it, right?
Yes.
And really, we could leave this, we could actually, instead of doing this check here, it makes a lot more sense to do it earlier on. And we just say that if it turns out that we should start processing, so we have an island, in that case, we would run DFS, right? And it should have an initial size. So I think probably the easiest is if I use a separate size outside of the DFS call. So let's say that size is equal to 0 to start. And over here, we would actually increment the value of size.
Why are you maintaining that as a list? Why assign the list?
It's because I'm using the, I could pass it as an argument, but because I'm using the a nested function within my existing max island function, this forms a closure and I have access to the size variable. But if I use an integer, this is passed by, it's a sort of assignment so that if I were to say that size plus equals 1, it takes the, it replaces the existing assignment and makes the size plus equals 1 only within this scope. But the size in my outer scope won't be affected. So when I refer to a list, my size value, the assignment isn't modified on line 32, and only the value within, the list assignment I have is modified. So the scope doesn't affect, the value.
How many elements are you expecting in this list?
It's only going to be 1. It's only 1. So the alternative for me would be to pass size as a parameter as well, And I'm just
Mm-hmm.
avoiding that and doing this instead.
Okay.
Yeah, I don't know if there's an equivalent for this in Java, but in Python, this is how I guess you handle using closures. Right, so ended up incrementing my size. I'm supposed to also, define what this options is, right? So my options that I talked about earlier, it pretty much ends up just being the different deltas of -1, 0, followed by 0, -1, followed by 1, 0, and then 0, 1, right? These are just the 4 directions that I can travel in. So for the new x, new y, instead of bothering with traversing all of the time, I would only want to traverse if the deltas are valid, right? So let's just say I have a function is valid xy, and what this will say is that I only want this to be within the bounds of the actual matrix, right? So I return that I could say that if x less than 0 or x greater than or equal to len of, or instead of bothering with len, I could just say if it's greater than or equal to m, I return false, because I shouldn't, go past the number of columns I have. Y is less than 0 or y greater than or equal to n, and I return false. And then ultimately I would want to return that islands of y x is equal to 1. This could all be one statement, but it just makes it simpler to see the, different conditions. So
this function is not just checking if it is valid, but it's actually returning the value of the island.
Well, it's not returning. This is a Boolean. It's checking if it is one, because if it's 0, then there's no reason we should be performing DFS there, right? We only want to search out in the valid spaces. So if is valid, new x, new y, only in that case we perform DFS. So really we can also kind of move this check up. False. Right, so this has to terminate eventually, right? So, and also do the size comparison. So let's think about how this would work. Let's say we have an island, and it's just 1, 1, 0, 1, with a 0 here. Let's just keep it one island for simplicity. And we start off at 0, 0, and we perform DFS. We see that the islands at 0, 0 is 1. So we add that to visited. Then we go ahead and check our different options. So we go right first, or really in the options list, we go left first and then up first, and both of those don't pass for is valid. So we get to the next step, and then we go right next. We see that this is valid because it's within the bounds of the array and islands of 0, 1 is equal to 1. So cool, we perform DFS on this new section. Right now, our size is 1. We add 0, 1 to visited, our size becomes 2. Eventually, we should go down, and we should end up seeing that there is no, there is nothing past the 1, 1 steps, right? So over here, once you've finished your recursive DFS calls, I think it's only then that you would say that the maximum is equal to the max of maximum. And again, we're going to have to use a list to keep track of these, just because we're not passing these as arguments, and we're just using them in an outer scope, and size of 0. And every single time we find an island, we're going to set the size back to 0. And then in the end, we return the maximum. The only thing that I'm concerned about is our place for where we do the comparison for maximum. It seems like, this is done at every step, right? It's doing the actual call in many more places than it's really required. Yeah, and though it's not explicit with what a base case in this recursive function is, I want to say that because after a while you won't have any options, right? This is going to terminate.
Yeah.
And the base case is almost that your options is filtered to empty, right? And you're going to end up doing the maximum comparison more times than you need to, because you're going to do it at the last step, then you're going to do it at the second last step, and then the third last step, and so on until you get to the very first node, right? But for correctness, I don't think it makes too much of a difference, though it's kind of, you know, wasteful.
Yeah, right.
Cool. Is it okay? I think that ends up being the translation of the idea I had. Is it okay if I run this on some test cases?
Yes, please.
Okay, so let's go ahead and make the island that we had from before. What was it? 1, 1, 0, followed by 0, 1, 0. Oh, it doesn't space. So I have 0, 0, 0. And here I know that the max size of my island should be 3, right? This is just a simple case.
Yeah.
Oh, local variable maximum. Did I spell it differently? Oh, it's supposed to be the maximum of 0 is equal to the max. Cool. So this test case is all right. So really the thing that I care about more is instead that, you know, there's multiple islands, right? So I should have some disjoint pieces. And I should be able to get the max between those. So how can I actually, let's make this one size 2, and then this one size 4. And it should be, yeah, it should find the larger of the DFS paths. It's 4. Cool.
Yeah.
Thinking of other test cases
that you want to test?
Yeah, there's definitely the empty list, which is pretty important. But I think for, you know, that you're just gonna get 0, right? Because the range in line 54 and line 55, those never get run, but we can run that. Oh, is this valid? I think this is the minimum input you can have, right? Like an empty list within an empty list.
Yeah.
Got it. So none and things like that aren't valid input, I'm guessing.
Yeah, this is the correct input. So what does it return for this? Let's check, right?
Cool. So we got 0 as we want. The only other test cases I can think of are really that if you add more islands, but I think that follows the same code path, so it shouldn't really make much of a difference. So given that, I'll leave that as my solution.
I would say a slight modification of this problem where it is not a square matrix, but each row has could be of a different length. Then would the program still work?
If each one is of a different length, so you mean that one of the rows is size 2, another row is size 3, and onward?
Yes.
Yeah, no, it wouldn't, because the m that we have is constant. So it's okay if, you know, it's not a 3 by 3. If it's 3 by 4, it's okay. But the mistake made here is that our m we assign at the top. Fix to make it work generally, I think, would be if you do something like this, right? Where we assign the length of m at every row we check. And if that were the case, everything else should work out the same.
There's one more change that you need to do. Can you find that out?
Okay, let's think about that. So if we have arbitrary length rows, the only thing that we're doing for, okay, right, my is valid itself, I would need to pass that down somewhere, right? So that's definitely a mistake. It seems like, what's it called? I need to pass this at every call of DFS, And I'd also need to update what the M could be when I update the delta Y, right? So
Yeah.
let's say that the very first time I pass the M as it is. So I'm just going to take M. But afterwards, what I'll need to do is set my, I guess my new M is still, yeah, it's still based on the new Y. So I just have that M is equal to len of islands at new Y. And I'd call that, yeah, but then is valid also needs that value M.
Yeah. There is actually a variant of this problem where you're asked to find the maximum size rectangle given a histogram.
Okay.
And this is not exactly that problem, but you have to do similar modifications for that.
Do you mean with the M portion or?
Yeah, because in case of histogram, since each line can have a different height, it is similar to this problem where each row in your land matrix that is given has different lengths. The slight difference in that problem is that it's not the maximum size island that you're finding, but the maximum size rectangle, I think.
I see. If that were the case, is it still DFS? Because you wouldn't want to travel in every direction, right?
You would travel in the same directions as you have. I mean, the modifications to the is valid that you have done is correct, or at least the direction is correct. But why do you say that you would not be doing a DFS in that case?
It seems like you wouldn't just want to, like for R1, we just start from some arbitrary point and we expand in every direction, right? For histogram and rectangles, you have to have, you know, it has to form into an actual rectangle, right? Oh,
yes.
It turns out I have an error here.
That's the difference. Yeah, I don't fully recollect that problem now, but for something like finding the largest rectangle in the histogram, maybe you need to look it up.
Sorry,
Excellent.
Cool.
I think that's that. I mean, you solved it really fast. I mean, that's really nice, and it came out correct almost the first time. I mean, you just had one syntax error, and pretty much it came right. So that's great.